Hey everyone, I'm David Room. Today we're going to be working on some low poly spacecraft antennas. And I talked a little bit about why we're working on this on the last little stream I did, but probably most people didn't catch that. So let me just quick bring up one of the ships that we're going to be looking at, and I'll kind of use that to explain what we're doing here. So just make sure X is muted. Okay, so, and we'll close out all this stuff here. Okay. I'll get our workbench up here and bring up So, for anyone who might be new, I'm using Python to do 3D modeling programmatically. And there are a lot of reasons for that. The primary one being that I'm a software engineer. I like doing stuff with code. And another reason for that is that another reason for that is that it sort of gives me a lot of different ways of, or like different possibilities for what I make, right? So if I were to manually model something like this, I mean, there would be some value and it would be a nice design, but I would basically have to start from scratch to put it into a different form, or I'd have to manually modify it to use it for other applications like 3D printing. Starting with a base of programmatic modeling lets me extend and make variations on things programmatically. And that's kind of what I'm going to be doing tonight. I want to come up with a different way of doing these antennas. You can see this ship has this communications array of these antennas that are angled back. We'll load this into Blender here. And the work that I do on this will sort of immediately extend beyond this particular ship to the other ships in my fleet, and both high and low detail applications. So the problem is currently, I believe, let's take a look in the model tree. Okay, so there is a empty that these antennas are parented to, but you can see that they're kind of arbitrarily placed. They overlap with the fuselage, and they don't really line up with anything in particular. They were placed just with a lot of trial and error, and I am programmatically describing the size of these things, but there's kind of an arbitrary overlap here, so I don't really know how far they're sticking out. The rotations are also kind of arbitrary. The one nice thing about the current method is that the coordinate systems of the antenna is sort of lined up with the antenna itself, but actually we don't really care about that so much. So as time goes on, I'm kind of moving to a workflow where we're more optimizing the coordinate systems of things for ease of building rather than something that makes physical sense. I think it's easy to go towards something that makes physical sense, but it's difficult to work with these things if they're created in such a way that they're not easy to build with. So let's let's take a look here at the current approach, and we're gonna basically build an alternate set of antennas that we'll have alongside the old ones until we have something that we're satisfied with for a new approach. Okay, so I think there should be a function here called com array. Yeah. So here you can see we're building the antenna just as a couple of ribs. So basically it's a cylinder, but you know, the two ends of the cylinder are different sizes. Actually, I can show this. And then we're doing some rotation of it here, and this is kind of hard to track as well. We have these different rotations that are going on in the mesh space. Then we're sort of enumerating these 4 antennas like this. It's kind of hard to track what's going on, and we're building this com array. So I think there's going to be a better way to do this. So let's just take a look. So this is what the base antenna piece looks like. And what I'm going to move to is something where the base of the antenna where it attaches to the ship is going to be at the origin, and it's going to be angled. It's going to be angled basically in YZ with the angle that I want it to come off the ship. And the reason for that is then in high detail applications I'll be able to add little brackets and other little details that kind of go with that angle, and I can describe it more accurately. And then we'll have to add some logic to actually place the antenna on the surface in a particular spot. So let's get started with that. So let me just, we won't open up Blender anymore for now. Just make a new com array here. Okay, so I'm going to copy some of this stuff just for now. Then the first thing that we're going to do is we're going to apply a rotation to this antenna right away. So we're going to basically do that, like getting it into the position that we want it in the mesh itself right away. So let me see here. Not sure what the point of this oh, I think I know what that is. That's just to align the, and this runs so fast it's going to be very quick to iterate on it. Yeah, that's just to align the ridged side the way we want it. Okay, so we have some of these angles described in constants, so we can reuse them. I think we have a y angle and an x angle. So let's apply that x angle right away. Actually, first we've got to translate it. So Antlin, so translate mesh, and I'm using, for people who are curious, I'm using my own mesh processing library, which uses NumPy and TryMesh, and most of the functions in it are pretty simple. It would be something that'd be pretty simple to write yourself. But if you have questions about how something works, feel free to ask, and I can dive into it. So we're going to translate this mesh y. Hey, Edward Menser. So two. So now it should be, yeah. So now the end is lined up with the origin. And actually, we're almost always going to have the antennas swept backwards, right? And the front of our ship is going to be pointing in y forward. So we actually want to flip this around. So there's a couple different ways we could do that, but this might be the easiest. This, I think we need to let's see here. Yeah. Okay. So now let's apply that X rotation here right away. And then, you know, once we kind of make sure this is what we want, we're going to break this functionality off into something that we can reuse. So take mesh, rotation X, X, and then let's just check the sign on this. Yep, that's the wrong way. Yeah. And that's odd. That seems like a high angle, but okay, yeah. Interesting. Yeah, we're definitely going to have to tweak some of these things. Let me actually just tweak that right away because I don't like the way it looks. Okay. So now, instead of having sort of a manual offset here, we're going to find the spots where these go by projecting rays, projecting rays onto the fuselage and finding where it intersects. So I think here we have this end offset, which we're sort of flipping around different directions. So I think we can reuse this. So we're gonna build a set of rays here that we're gonna project. And there's a number of different ways we could do this. We could do rays, or we could just do like orthogonal projections to the mesh. But we'll do rays here because I think that's going to be basically the thing that's the most similar to what we have, and I like the current design. So we want to come up with something that looks similar. So let's see here. So we're gonna do a ray where our point is going to be, whoops. And let's see here. This one, I'm not sure what directions we're going to have this go. So we'll just start with this and see. So basically, these are going to be the top ones. These are going to be the bottom ones. So whichever, just have to flip the signs for whichever. And then we'll find the intersections here. Simple. And our mesh is going to be the fuselage. Okay. Yeah, okay, yeah. Simple is just assuming that there's one or none intersections per ray. Oops. Intersections are kind of tricky because, you know, you might have multiple. There's just different cases that you have to deal with. So for inter and inters, we're just going to assume that that they're not none for now. And let's see. Result part set. Actually, Is going to be inter dot point, and then we have to just come up with the rotation here. So the rotation is going to be so let's see, there's a function called that let's see here. So this finds a rotation that basically is, so like a normal is like 2 out of 3 components of a rotation, right? If you have a normal that points in any direction, there is a whole set of rotations that will take unit z to that normal, because you can take it to that normal and then, you know, basically rotate it around. So here, find panel rotation is finding a rotation that goes to that normal, basically just in terms of y rotation and an x rotation. So we're not going to have any extra spinning. Basically, it would sort of keep parts aligned on the exterior of a spaceship that's pointing in the y direction. But then we're going to add on an additional rotation, so which is going to be our z angle, we'll call it. And then this, we've got a figure out which direction we're rotating depending on which side or top bottom that we are. So we'll figure that out in just a second. For now, we'll just leave that to be identity. And then we'll compose these two. So we compose our rotations with the add operator. Left multiply. And add our parts. So part. Okay. Return our results. So now when we run this, we should have 2 sets of antennas on our spacecraft, and we can start using that to kind of compare and make sure that our new approach is doing something like our old approach. Okay. Transpose. Okay. So yeah, we were just missing adding Gotta make these new so they're distinct. And this guy has to be parents is fuselage, so it's not a separate part set. Okay, good. So this is what we're working with now. So this is really similar. So here's our new ones, here's our old ones. But this should be much easier to tweak now in terms of where we want these. Let's try to get that Z rotation on there. And it looks like we want to flip these the other way as well. And then you can see with this approach, we're going to have to add a little extra back on, right? But we now are, putting the origin where we want, so we can add a specific amount back on instead of having this kind of eyeballed offset. So this is exactly what we want here. Okay. The fun thing about this approach too is it's very fast, especially for low poly stuff, so you can iterate on designs pretty quickly while keeping the non-destructive aspect of it. Okay, so we want to get rid of... Actually, we want to make this negative 90, I think. Yeah. Okay. Now... let's sort of make this descriptive here. So right, I've got to swap out my headphones here too. Actually, I think I can just make them wired. Just 1 second here. Okay. So, yeah, let's list out the sort of describe how these are positioned so we can trace our logic through later. So the positive x is going to be left, right? So we'll call this positions side. Actually, left equals true, top equals true. Yeah, so let me just double check and make sure this is right. So here we're flipping. Yeah, we're starting on the top left. So now we can check that position. So if pause stop see. We'll just go through the different combinations here. So, and then we can just flip the signs if we get it backwards. So, and then I think let me just think about this. When we flip over to the bottom, we're going to want to reverse the direction of that. So well, we can collapse this down to a tighter condition later. Don't want to get too clever with it right away. Missing yeah. Okay. So it looks like they are going just need to be flipped like this. So maybe my intuition about how they flip top to bottom was wrong. That's okay. Yeah. Okay, so now we just have to tweak our positions and angles to be similar to the original. So it looks like that Z angle needs to come out a little bit. Yep. That's pretty close. And then we just have to decrease this X angle. Yeah. So that is quite similar. The main difference now is just that the position at the base needs to be tweaked a little bit to pull them back and push them out a little bit. So let's tweak that and see. This gets way easier to control now too. So Now let's double check again how we want to tweak these. So just maybe moved oh yeah, and I could actually add a Y angle too to align them that way as well. So it looks like we want to move out a few centimeters and back a few centimeters. So and this is really more of an exercise in this is really more of an exercise in, you know, how well does this method work for placing things where I want them than that it's really important to place these exactly where the old ones were. Okay, yeah, they can still come out a little bit more. And I definitely want yeah, what's going on here? Actually, I might look at this in Blender a little bit. I want to understand how I have these rotated. Let's see, if I rotate this around it's not clear to me what I have to do to get this to look the way I want it to look. Let's take a look again. Oh. I think I... I just want this, right? Yeah. So that was correct. More or less. Let's take a look. I think these actually look pretty good, and I think let's just compare old versus new. I think the new coordinate systems make a little bit more sense, but I think we can always get back to the old one just with a little bit of extra or a little different Y rotation on it. And I'm only thinking about this because this is like the low poly setting. For high detail, we're not going to be using like this three-sided thing, probably. And these still need to come out a little bit. A little bit. We're getting closer. Almost there. Okay. All right, so now let's tweak a couple more things. So we want to add the extra length. So oh, nice. Actually, I don't even have to bother with this because we can just construct it right in the proper coordinate system from the get-go. So the small one is going to be at constant amp len, and then this one is going to be at minus. Oh yeah, it's so much easier to do that than trying to. It's pretty simple math, but it's always annoying to reason through how things are going to be lined up. Now let's see if... Yeah. Yeah, that's looking pretty good. Yeah, actually, I'm going to bring that up once more and look at it with wireframe and transparency on. Yeah. Okay. Oh, nice. Muscle Boutique says, cool spaceship, bro. Hey, thank you. Okay. Well, I mean, I think that kind of proves out this approach. Let's move this antenna to a shared function in our ship devices code, and then swap it out, get it in the game, in the renderer, compare, see if we notice anything goofy about it, or if everything looks good. I eventually want to add the sort of high detail stuff out, but I think we've done pretty well in proving out this approach in a short period of time. So I have this module called devices that has a lot of like reused pieces of spacecraft, and I don't think I have yeah, I don't have a antenna function, so we'll just do a basic antenna. And what do we need? We want our so we can have our log first. I don't know exactly what the high detail version of this is going to look like, but we can get to that when we get to that. I guess we'll just do length and length extra. Oh, interesting. I have this too. I forgot about this. Yeah, okay. So this kind of describes from one end of the antenna to the other how much smaller the small end should be. And for low detail stuff, we still want it to stay pretty thick. But for high detail stuff, it can get a lot thinner. Yeah, and then we want the angle X. Actually, this can just be angle because that's the only angle that we care about in here. So just fill this stuff in here. And angle equals X. Yep. There it is. Okay. Just add a little note to ourselves here. We need to add a like base support details. So I control the detail with this LOD argument. For the game, 0 is the highest detail, and then negative numbers are higher detail for the high detail workflow. I have a high detail antenna somewhere. I'm not sure where that ended up. I think it was actually in the needle. Yeah, this is where I add a base to the antenna, so we could reuse some of that at some point. Okay, let's get the new antenna in here, kind of replacing the old antenna, and make sure everything looks good. Okay, so now we can generate all the game assets. This is fun, how quick it goes. Oh, actually, I need to fix the names here. All right, there it is. I mean, it looks pretty much indistinguishable from the old version, as it should. Yeah, definitely not anything that stands out in a negative way. Whoops. Yeah. All right, well, let's just actually, before we're done, let's look a little bit at the logic here and see if there's any more we can do to clean this up. Oh, Sergio Valeria says, great finding, subscribing. Well, thanks. Are you interested in Python programming or 3D modeling, or I'm curious about what brought you here. It's fun to talk to people sometimes about what brought them to the channel. A lot of people learning Python programming or working on programming projects themselves, things like that. Oh, nice, the algorithm. Some people complain about the algorithm. The algorithm is great. Actually, yeah, so what I'm going to do here is we're actually going to combine these two together, just for clarity. So we'll do grazing positions like this. Oh, nice. Yeah, I really like YouTube just as a way to find fun stuff to watch. And one of my hobbies is music. I play a lot of bluegrass music on the guitar, and the algorithm is really good at recommending good small channels. So like for bluegrass, there's a bunch of big channels. Some of them are good, some of them aren't, but there's lots of lots of little bands that have like, you know, have like 100 subscribers, and maybe they have one video that's got 1,000 views or something, but there's some really good stuff there. And like, if you keep watching, the algorithm starts showing you these awesome deep cuts. It's great. Okay, so Chaser says that the algorithm brought me here too, but I can't understand why pure Python for 3D modeling versus Blender. What are the benefits? So that is a really good question. There's a few different things. So for starters, what kind of got me into this project is I had wanted to do game design for a long time, and I really like programming, so I'm a software engineer by trade. But and I wanted to do some like 3D programming, but the thought of like spending a lot of time clicking around in Blender really bothers me. I like the idea of making things with code and being able to track changes over time and extend things and rewrite things. And I had done a bunch of work in my day job with 3D mesh processing, and one day I realized, wait a second, I can actually just write code to make these game assets. What also makes that possible is my game is sort of like a low poly style, so the models don't have to be super complicated. I do actually have a high detail workflow, but especially for this low poly stuff, it's not that hard to describe what you want with code, so that makes it easy. And then there's some other benefits too. So I like being able to describe things exactly, like say this part has exactly these dimensions and is exactly this position. That's pretty hard to do in Blender. It's easier to do with code, so that's another benefit. And then something that I also talk about is having this workflow in code. You can kind of start with the low detail stuff, then extend it into high detail, use code to transform it between different forms. Like I have projects going to turn these models into like high detail models, things for 3D printing, the game assets, all that stuff. So it, like, working with code kind of makes it so that I don't have to start projects over from scratch. I don't have to destructively modify stuff. I hope that answers your question, Chaser. And Sergio Valerio says, but I do like programming in Python, anything via AR. I have been involved for a few years in art. Overall, this type of programming areas are great intersection. Yeah, there's definitely a lot you can do, and I think what I'm doing is a little unique. You see a lot of people trying to do procedurally generated stuff where they try to come up with an algorithm that will like automatically generate a whole bunch of different spaceships or something, and that's not necessarily what I'm doing. I'm sort of using code to make the designs that I want to see, rather than trying to develop an algorithm that will do everything. I could kind of do the latter, but I still want to design ships and have them look a certain way. So that's kind of also why I'm taking the approach I'm taking, is I want to have some control over things. So okay, so Edward asks what libraries are you using to render the models and for the game itself. So what I have up here is the game engine, or the rendering in the game and the game engine. So the engine I'm using is called Panda 3D. It's a kind of older, sort of outdated engine that was developed probably close to 20 years ago originally by Disney, and Carnegie Mellon took it over. The reason I'm using Panda 3D is because it's one of fairly few game engines that have a nice Python API, and I work in my real job in machine learning and computer vision, so Python is kind of like my language of choice. But the other thing that is kind of nice about it is that it is an engine that is older, and I'm developing a game that has kind of an older style. So some of the defaults and way things work just kind of work nice for the kind of more outdated, I guess, rendering pipeline that I'm using. The when I'm doing stuff in my programmatic workflow, like I've been showing, like when I let's see, when I run my workbench script and whoops, oh no, what happened? Oh, I peeled off the wrong things here. So this needs to be X. And this needs to be Y. This sort of model previewer that I have, this is using a great library called Polyscope. So I actually just recently started using this, and if you look back on my channel, there's some streams where I actually built this viewer. I was previously using a viewer using a different library. I forget what it's called. It worked pretty well, but it kind of didn't play so nice with Mac. There's some glitchy things, kind of just in stupid stuff like how the windows would open and close. The neat thing about Polyscope is that it's really, really simple, and it's instead of building a scene graph and doing lighting and stuff, you just kind of toss everything in a big list, and it lets you kind of interact with things to view it easier. And it uses something called matte caps for shading, and that works really well for previewing. You don't need fancier stuff. I did actually make some modifications to how it uses the matte caps for rendering, and my modifications aren't perfect, so I haven't like tried to share them back, but basically yeah, basically there's some things I don't like about the way it renders by default, but they were pretty easy to fix the shaders to get it to do what I want. So okay, so Edward Menser says, I'll have to check that out. I'm a software engineer too. My work is surprisingly similar to this type of stuff, minus the game aspect. Yeah, that's cool. I wasn't doing work where I was constructing 3D models, but I was doing a lot of work with 3D data, and then I realized, oh, like I'm kind of familiar with this stuff. I could do this stuff programmatically. The one thing that you probably would have to do if you use Panda 3D is shader programming, but that was also something that I wanted to learn. So part of what I did for my game is write a set of custom shaders that do the rendering, and I have this particular style where I'm doing this all vertex color workflow, and there's like some basic material properties, but then there are also soft shadows, which the Panda 3D engine has its own default shader pipeline, and it didn't support soft shadows, so I had to figure that out. And there were also some bugs in their pipeline. And then I have some custom shaders for like the different emissive materials and the post-processing. So it's probably not very easy to see on YouTube, but there is actually, oh, I think I have it turned off. I have like a film grain. I have a film grain and a glow on stuff. Yeah, there we go. That really makes stuff look a lot nicer too. And I had to work through some issues with this because I'm on Mac, and there's different things that different issues that Mac has with certain versions of OpenGL, and some of the built-in stuff with Panda 3D didn't work too well. But I don't know, if you're interested in learning about shader programming, there's a really great Um, there's a really great tutorials series by this guy called David Lettier, called 3D Game Shaders for Beginners, and this actually uses Panda 3D, and I kind of followed his tutorial when I was building my shaders. He does texturing and a lot of like more advanced stuff than what I'm doing, but he kind of shows how to build this whole pipeline, and you can kind of pick and choose whatever parts of it you're interested in. And if you're at all interested in like 3D math, you know, geometry, learning how this stuff works, I'd highly recommend this tutorial and just kind of diving in and, you know, seeing what you come up with. It was really interesting for me just because I've been playing games my whole life and I had vague ideas about how this stuff worked, but it's interesting, and I mean a little bit disenchanting to learn how it works, but it's fun. Yeah, you should definitely check this out. So yeah, okay, so he says, I'm trying to get into game development now that I've been doing the software side for a bit. Yeah, I mean, that was kind of my realization. I got into programming as a kid because I liked programming games, but I never did graphical stuff too much. When I was in high school, I had a project where I was developing kind of a Super Nintendo style RPG, but I never did 3D graphics, and then all of a sudden it was like, oh, I actually have the background that I could do this now, and it's been really, really fun and rewarding. So, let's see here. Yeah, I like this a lot better. Let's just clean up some of our imports here. So, people in the chat, Edward and Chaser and Sergio, what programming languages do you use? I mostly use Python, although in my day job I've actually already have it imported. I actually have started using C++ some. I used it a long time ago, but I'm getting back into it now. And Panda 3D is actually written in C++. It just has a Python wrapper. And someday, if I had time, which I probably won't, it would be kind of interesting just to try to actually write a game in C++. Oh, nice. Edward says all sorts between TS. I'm assuming that's TypeScript, Python, and whatever the task calls for. Nice. Yeah, it's good to be flexible and be willing to write stuff in different languages. I've used a ton of different programming languages in my work, but I really like Python the best. I think it's a really great language. Sergio says, long ago C, now more C# and Python as I got into ML and hobby work with Unity. Oh, nice. Sergio, do you do machine learning like for your day job? I've been working in machine learning for close to 10 years. Now actually more in computer vision, but it's a fun field to be in, and Python is a great language to work in. Chaser says C#, JS trying to switch to more professional Python, but for my day job more like software architect mixed with DevOps. Okay, cool. I don't have very much experience in that side of things. Okay. Sergio says, I moved from development after 20 plus years to leadership, so I just try not to get rusty. Nice. Yeah, I think that's important. For me, part of the reason that I got into this 3D stuff is I was doing a lot of work in my day job with 3D, and I really loved it. And then I kind of had to move on to different projects, even as extreme as stuff like NLP that wasn't involving geometry at all. And I was really frustrated by that at first, but then I realized, oh hey, I can just do this stuff on my own time. And then I don't have to be frustrated about not being able to do it at work, and I can kind of stay, you know, keep it fresh in my head. And actually now in my day job, I do work with 3D again. So, and I think part of the reason that I got that job is because I had kept it fresh with this project in particular. All right, well, why don't we actually see if we can use this new antenna technique that we have. I think I like how this looks pretty well. This is quite easy to read as far as which rays are going where. Oh, I suppose actually I should try to revise this. It's left. Let me just double check that I did this right. Left. False, false. Once we get this cleaned up, we will fix up another one of my ships using this new antenna method. So I think both top and bottom, yeah. So if pause is left, go this way. Is that right? Yep, that works. Cool. Yeah, we will adapt this to a different ship. So I feel like Blender's gotten slower in this new version at loading stuff in. Let's look at the needle. That's going to be a good one for this. Because there's like a very nice clear surface where the antenna is going to sit. Oh, nice. Quentin Lattimore says, what is going on here? Algorithm brought me here. So I am making these low poly spaceship models using Python code to do the 3D modeling. So I'm viewing them in Blender right now, but I'm actually building them with Python code. And tonight I am working on redoing how I am attaching these little antennas. So I had a method where I was kind of hard coding and eyeballing where they went, and now I'm doing something more principled where I am building the antennas themselves with coordinate systems that make sense and attaching them to the surface of the ship in a more sensible way. Yeah, let's take a look at the needle. And then another time we'll look at the high detail version of this now, which will be easier. Which will be easier now in this with this new approach. So there's the needle. Just bring this guy over here. Yeah, and see here, I'm, instead of placing them manually, I'm sort of spinning them around the ship. But there's better ways I could do this too, and I could spin the points and raise even, but kind of keep this new antenna design. Okay, here we go. Quentin Lanmore says, "Oh wow, that's nice. I've always wanted to dabble with Python and Blender, specifically automating certain repeated steps like adding a bevel and subdivision modifier." Yeah, so I have a workflow for doing that. I'm not using that too much today. I'm mainly just using Blender as a viewer for 3D stuff. But one thing that I'll point out that's kind of a unique thing that I'm doing, as opposed to maybe an approach that other people take, is I'm doing like all of my code in Python, and I'm using Python to generate sort of a scene graph that is loaded into Blender and then describes things like modifiers that I'm applying. I'm not actually writing Python code that's primarily running inside Blender. Like, I have sort of a generic thing that runs inside Blender that loads the scene graph in, but most of the heavy lifting is done in Python, just separate from Blender. So I'd encourage people, depending on what you're trying to do and how you're trying to automate things, like don't necessarily dive right into like writing Python code inside the Blender UI. That may or may not make sense depending on what you're trying to do, especially if you're trying to automate maybe a lot of different things, like repeatedly loading different things in. There might be different ways to approach things. Okay, so we know we're going to want to copy this. Well, actually, no, we don't need to copy that anymore because that's now in our thing. Actually, okay. So our angle here is going to be our this is going to be, yeah. So then our result. Again, we'll start with giving it a separate name. And this is my own system that I built for building scene graphs of just simple 3D parts. Okay, so we were doing positions by spinning parts around the y-axis with that offset. Yeah, okay, so what we can do instead is we can say points, we can do a circle, and it looks like a 2-meter circle with no offset, and we'll have 4 for index, point, in enumerate points. Nice. Chaser says, those spaceships bring back nostalgia for the times in my youth when I spent hundreds of hours in EVE Online. That's cool. I never played EVE Online myself. I had friends who did. I more played single-player space games like TIE Fighter and Descent Free Space and games like Mech Warrior. So that's kind of what is the inspiration for my game that I'm making, is those kind of more simulation-like games. I know EVE is really intense, but my understanding with EVE is it's more of like a space fleet management type game rather than like you're piloting individual ships. Am I right? Second. Okay, there it is. That's what I was looking for. VY constant Y. Oh, and we got a deploy mesh out here too. Yeah, so Chaser says, yeah, the fleets are at the core of EVE, but each individual spaceship is still controlled by a person. Oh, that's cool. And there's a lot to do alone in the game. Yeah, I know. I had friends that were always talking about spreadsheets and things like that. My friends that played it were playing it in college, like while we were studying computer science. I'm like, I don't have time for that. Oh, they seem to really enjoy it though. Okay, so you can actually do this and this origin, and then our array is going to go from our 3D point to a point that goes from our point to our origin. And we don't have to do the side thing here because there's radial symmetry. Okay. Now we can intersect. Trace. Just note that we're assuming none. New index, and again our rotation is going to be details dot find panel rotation of enter dot normal transpose. And yeah, we don't need any additional stuff here at this point. So then our part is going to be a part where our parent is array new. Model is our ant. And our transformation is a translation of inter.point. And oh, that's not quite right. So I want to subtract inter.point here from origin. Or subtract origin from it. Yeah, subtract origin from it. And then this guy, let's see, this guy is gonna have that translation here. So parent is fuselage, translation of gotta stick this guy into res under key. And then I think that does that. So now we just have to, we're gonna do like we did before and kind of test both of these side by side. Let's see. And this, there's definitely some tricky aspects too, so I'm not necessarily expecting it to work the first time. But yeah, okay. So it looks like we did end up with none. So let's visualize this. Where was that? I had a function for viewing a mesh along with some points. View mesh with points, there it is. So we'll see if our points are what we expect. And let's see, our rays are pointing back towards the origin, so that's would be like an obvious thing. That I could have gotten wrong. Because oh. Actually, I think I did that backward. Yeah, okay, that was it. Derp. Okay, so... Yep, so... Looks like a couple things we need to flip. Flip these around. And add an offset here. So the angle offset is going to be tau divided by 8. Yeah. Sweet. So if we look at this now, if we turn on transparency, you can see what's going on here. So the current antennas are so long that they're actually way in here. And I think they're there's like some other whoops, wrong function. Yeah, we're also shifting them away from that origin. So let's actually y should be, yeah, it's like -2. And yeah, this is a y offset. So let's try if we just bring our origin forward, if it looks better. That's too far. What happened? These too far forward? Okay, yeah, the new ones are too far forward. They need to be shifted back. Yeah. That's really close. Now, let's get the right. Just manually kind of tweaking this. I can put these things into better constants later. And our X angle should be actually bigger here. So something like yeah, that is really close. So now if we just shift this, is it back too far? Not far enough. This. Yeah, okay, and then just kind of like before, we have to subtract some off of our antenna length because we have this extra length that we're not needing anymore. And to actually match exactly, we would want to rotate that around, but I kind of like the let me see, kind of like that flat side facing forward. I like how that looks better. So this is, I would say that's a win. And if we look at this too, I think the new code is quite a bit simpler than the old. So if we look at it side by side, whoops. So the old code, I mean, we were building the antennas as well, but the new code basically just spins. This is kind of a trivial thing that could probably be rewritten in a simpler way as well. This is, yeah, it's kind of overly complicated. Yeah, this is, I'm pretty pleased with this. This seems like a good method. Kind of tested it in two different scenarios. One where we were placing the antennas kind of manually with left-right positions. And then another scenario where we were sort of spinning the antennas around the ship and sort of manually adjusting an offset. And in both cases, this new method seems to work pretty well. Let's actually just quick kind of switch this over like we did with the other one to use the same name as the original parts. And then we can swap it out. The fun thing about code, right, is if I ever decide, hey, I don't like this method, or, you know, that looks weird. I liked the way it looked before. I can't talk and type at the same time. I like the way it looked before better. It's just, you know, reverting to an older version of the code to switch it back. There's no content to manage. It's just code in the Git repo. Need to regenerate. Just make sure that this is working, and then we'll call it good. I'm especially anxious to use this approach on some of these bigger ships where I have like multiple antennas mounted on different parts like drives and stuff. It's just kind of a pain to manually be tweaking that stuff. Yep, well that looks great. I'm pretty pleased with this. And then see, like for the high detail versions, we can add little brackets and braces and things that line up with that angle that it's coming off the surface that it's on and everything. That'll look really nice. Cool. Well, I think I'm gonna call it good here for tonight. But thanks everyone for watching, hanging out. It's always fun chatting about programming and other people's projects. I hope that you are inspired to work on some of your own game development or 3D projects, and I hope to see you back here sometime. And if this is interesting, I have a ton of previous live streams recorded, multiple different topics, both high detail and low poly 3D modeling, game development, and some general Python stuff as well. So make sure to check out my channel and check out some of that backlog. But all right, yeah, have a good night, Edward, and thanks to everyone else who came too. It was really a fun time hanging out and chatting. So have a good night.